So let's talk about linear regression. So if we think about visualizing our scatter plots, remember we said that we could see that either there's a strong or a weak relationship, either there's positive or negative, maybe there's no relationship. But a lot of times, especially in strong relationships, we can see that they do kind of form close to this line. That they kind of seem to all be falling within a similar pattern. So this seems to model maybe some type of line here. So this line right here, so the line that seems to best fit the data is called the least squares regression line, or maybe you've heard it as the line of best fit. Now, how we come up with this line, there's a whole lot of mathematics that go behind there. So there's like a 400 level math course in which we work through all of the information about how this equation gets created. But for all that you need to know is that the goal is that we're going to try to minimize how far away each data point is from the line, assuming that the x value is correct. So basically saying assuming this x value is correct, basically we're trying to minimize all of these distances between the data value and the line. And we're going to take those differences and we're going to square them. And so we're going to try to minimize all of those squares. So that's why it's called the least squares line, is because you're squaring these distances. It's often called the deviations. All right, but the process of finding a least squares regression line is called linear regression. So when we talk about linear regression, that's the process of finding this line. You could do other things like logarithmic regression or exponential regression or some of these other ones in which you're going to try to find either a logarithmic function or an exponential function or even a quadratic regression. You're trying to find a quadratic that models this. So we have linear regression for the line. Now, one of the main reasons of why we even care about this line, because yes, we can find this line, it's great, it's cool. One of the main reasons for finding this is to use it for approximation purposes. We have so much data here that if we try to make approximations, we have no way of making estimates of what would happen if I ran this again and I had an x value here. Well, the least squares regression line would say, well, if you ran this again and this was your x value here, I would guess that that would probably be your corresponding y value. If I want to say, well, what about this x value, I could again look at that corresponding y value. And you can use this for approximations. So we'll work through some examples in a different video of how we use that for approximations. But it'll be very simple by just taking the equation of the line and plugging numbers into it and solving for the other. Now, when we do use the least square regression line for approximations, we are either going to be doing interpolation or extrapolation. So there are these two new words, interpolation and extrapolation. Both of these is the process of approximating things, right? If we're, again, looking at this data set here, and this is my least squares regression line, I'm making an approximation by using the line. So interpolation says that when we approximate data values within the range of our collected data, that is interpolation. So right here, what I did, this would be an example of interpolation because I'm within the realm of the data that I collected. Same thing over here, let's say I was to be this point right over here. If I was to approximate this data value, again, I'm doing interpolation because this is falling within the range of the given x values and the given y values. But then extrapolation, on the other hand, that's going to be when we approximate data values outside of the range of collected data. So example would be over here. If I wanted to approximate, if I had this x value, my approximated y value would be this. This process of getting this approximation, this is called extrapolation. Or if I went in the other direction, I'd be like, oh yeah, what about if this line, because mathematically lines keep going in both directions forever. If I was to say find this value over here, I would then approximate that would be this. And this, again, would be extrapolation. So when we look at these two, which one do we trust more? Do we trust approximations that come from interpolation or those that come from extrapolation? Well, hopefully you think extrapolation seems a little sketchy, right? How do we know that this relationship is going to continue on forever? So interpolation, we can trust a little bit more. Extrapolation, we get a little bit concerned. So really to do extrapolation, there's a lot more advanced techniques that you do to do this to do a quality job with this. And this is going to be especially true when we go really far away, right? Because if this keeps going on forever, then if I'm way out over here, we're like, I don't really know if that is going to continue on forever like that. So we'll see some good examples in which extrapolation can lead to some really weird results, but interpolation is usually very trustworthy.